Hello, this is Harold for Dr. Miller's stats class, the 5.0, lesson 5.0, dealing with correlations. As we know, uh, correlation is defined as a measure of linear relationship between two um, quantitative um, variables. Yes. Okay, so in understanding correlation, there's also correlation coefficients, which are three that we'll talk about. You have Pearson's, you have Spearman's, and Kindle's. So with Pearson's, Pearson's is used as a technique to investigate the relationship between two quantitative and continuous variables. Spearman's is used to evaluate the relationship um, of, of ordinal variables, thus having, I guess, an ordinal scale, whereas Pearson's has an interval type scale. So which leaves now Kendall's Taw, and so Kendall's is used when the data um, worked on has failed one or more assumptions of the test. So you have this non-parametric measure of strength and direction um, of the association of the two variables. Okay, now let's move to what we call point biserial correlation and biserial correlation. So point biserial correlation is used when dichotomous variables is seen as being true or discrete dichotomy, and the biserial correlation is used with an artificial dichotomy. Okay, but what's important is that both are used to correlate a dichotomy with an interval type scale. Okay, so now moving on to what we call partial correlation and semi-partial correlation. Partial correlation is explained as a correlation. Um, oh shucks, is a correlation with two or more continuous variables with, let's say, x3 as constant for x1 and x2, and semi-partial correlation is measures the linear relationship of two variables, let's say of x and 1, whereas x3 is held as constant. Yeah. So, yeah. Okay. I believe that's kind of close or something like that. So you have that, which now moves us to what we talk about as the correlation coefficient and causality. So correlation coefficient, as I understand this, is a statistical measure of strength of the relationship um, of oh is a statistical measure of strength of the movement, if you will, of it's yeah of the movement the relation. Oh, okay, is a statistical measure of strength of the relationship between the movement of two variables. Yeah. And whereas causality shows the, how do you say, shows where one variable directly affects the change of another. Something like that. Hope I haven't confused you.